Hi, Assalamualaikum. We are from Section 2, Group 7. We present our design simply supported beam and continuous beam. These are our group members. I am personally Intan Nur Asma Zalina, and beside me there has another 4 members, which is Shankara Nathan, Nurul Aisha, Lo Chi, and Rafaela Alexandra.
Although we will encounter some peculiar aspect of behavior of concrete members, we will usually be close to a solution for most problems if we can apply the following 3 basic ideas. First, geometry of deformation of section will be consistent under given type of loading. For example, moment will always cause strength to vary linearly with distance from neutral axis. Second, mechanics of material will allow us to relate stresses to strength. And third, section will be in equilibrium, which is external moment will be resisted by internal moment. External axial load will be equal to the sum of internal axial forces. In this project, we will learn to understand the basic performance of concrete and steel as structural materials, and the behavior of reinforced concrete members and structures. If we understand the basic concept behind code provision for design, we will be able to approach the design in a more knowledgeable fashion, not like following a black box, and understand and adapt the changes in code provision better and faster. Our project objective is, first, design reinforced concrete member and basic structure by applying methodologies of design, codes of conduct, and specifications. Next is, apply and enhance structural analysis and material strength knowledge. Next, include the correct application of contemporary engineering technology for communication and problem solving. Last but not least, build your ability to make decisions, provide a space for autonomous thought, and support productive cooperation.
Hey guys, my name is Shankaranathan and I'm going to present about our drawing plan. Okay, for the initial start, we were asked to choose one architectural drawing where we have to draw three different types of structural layout plan. But for this instance, we have drawn the ground floor plan. Okay, and this is our first floor plan and also roof plan. And we were asked by our lecturer to be checked with him before continuing with this drawing plan. That's it.
Analysis of action. For characteristic action, permanent load GK will be sum of concrete surface and finishes. The finishes are carpet, plaster skim coat, plasterboard, service, and tile ceramic depending on architectural drawing. All the values used are referring to the Eurocode and Malaysian standard. Next is the constant specification. Variable load QK is 3 kN per meter square because it is a common building, and the slab thickness of the building we are assuming as 150 mm. The other values such as unit weight of concrete, unit weight of brick wall, fire resistant, FYK, and exposure class are also referring to the Eurocode and Malaysian standard. After designing simply supported for beam K17A26A, it concludes that the beam is singly reinforced because the value of K is 0.004 less than K balance, which 0.167. Area reinforcement bar that required for this beam is calculated to be 123 mm square, and referring to the standard area reinforcement bar provided for this beam is 157 mm square, which 2H10. After checking the deflection and cracking, the spacing of the main bar is H6-100, while link bar is H6-300.
Okay, now I'm going to present about my simply supported beam, which is L9A70. Okay, the K that I've got was 0.026, which was smaller than K balance, and this made me to use singly reinforced equation. And the AS required that I've got was 182.87 mm, and the AS provided was 198 mm, which is 7H6. For the spacing bar and the spacing link bar I have chosen was H6-300.
After designing the simply supported beam, which is beam 10SC, it can conclude that it is singly reinforced because my K balance is bigger than K. My K balance is 0.167 and K is 0.127. And for the S requirement is 182.87 mm square, and S provided is 285.58 mm square, which is I chose 4H20. For spacing bar, I choose is H275, and for spacing link bar, H6-125. So this is the picture of detailing of beam 10 SC.
Hi, Assalamualaikum. My name is Intan Nur Asma Zalina binti Muhammad Azhanizam. My metric number is CF210138. For simply supported, my beam is on 12AJK. And for the K value, I got for 0.08, which is lower than K bar, 0.167, and it's singly reinforced. For AS rate, I got for 141 mm square. For AS proof, I got for 157 mm square, and used for 2H10. For spacing bar, I use H6-100. For spacing link bar, I use H6-120.
First, calculate the effective depth based on the cover, assume link and bar diameters. Next, calculate the K. Check the K. The K must be less than K balance, which is 0.167. If this is satisfied, the beam can be designed as singly reinforced, or otherwise it shall be designed as doubly reinforced section. Based on my calculation, I am able to conclude that the beam is singly reinforced. Then, find the level arm. Check the level arm. The level arm must be less than 0.95D. If satisfied, use the same, or otherwise use jack equal to 0.95D. Then find the AS required. The AS required must be checked with the rank of minimum and the maximum reinforcement area. In order to provide the area of steel, we must base for the area we obtained from the calculation of AS required. As on my calculation, I got the value for AS required is 176 mm square, which between 85 mm square and 2880 mm square. Therefore, I provided the area of steel is 628 mm square, which is 2H20 to resist tensile stresses, and 2 additional bar are provided in compression phase of the beam. The area provided is 402 mm square, which is 2H60. After checking the deflection and cracking, I designed the spacing for the vertical shear link is H6 125, while the minimum link near to the center of the beam is H6 275.
For designing continuous beam for beam L126A, it concludes that the calculation to get the area reinforcement bar is at span 2A to 4A and at the support of 4A because there is a maximum value of moment and shear. At the midspan, the beam is singly reinforced because the value of K is 0.0036, less than K balance which 0.167. Area reinforcement bar that required for this beam is calculated to be 180 mm square, and referring to the standard area reinforcement bar provided for this beam is 157 mm square, which 2H10. While at support, it is a singly reinforced because the value of K is 0.0038 less than K balance value. A reinforcement bar that required for this support is calculated to be 125 mm square, and referring to the standard area reinforcement bar provided for this support is 157 mm square, which 2H10. After checking the deflection and cracking, the spacing of the main bar is H6 100 while link bar is H6 300.
After design the continuous beam for beam J7A to A, the maximum moment is at the span 7A to 9A. It can conclude that it is a singly reinforced because K balance is bigger than K, which is 0.167 for K balance, and for K is 0.07. And for the S requirement, it is 166.92 mm square, and S provided is 452 mm square. So that is why I chose 4H12. And for maximum moment is at the span 9A, and it can conclude it is a singly reinforced because K balance is bigger than K. For the AS requirement, it is 173.55 mm square, and AS provided is 226 mm square. So it is a 2H12. For spacing bar, it is a H6 56.6, and for spacing link bar, 2H12. So it can see it here. This is the detailing for the beam J7A to A.
Okay, for the continuous beam, I have chosen the beam 1AL, which is located in the first floor. Okay, it goes same. For the maximum moment at span 1AG, the K value that I've got was K0.18, which is bigger than K balance, and this made me to use doubly reinforced equation, where my AS required was 234.66 and 1693.87. This made me to choose for the AS provided was 3H10 and 9H16. This goes for the same thing for the next span, which is 1GL, where I have to use doubly reinforced equation, where I have chosen 10H12 and 10H20 as my AS provided. And for the spacing bar and the spacing link bar, I have chosen H6300 as my chosen links. That's it. Thank you.
For continuous beam, it's on beam 1 AL, also ground floor. For maximum moment at span 1 AG, for K I got for 1.3, which is more than K bar, 0.167. It is doubly reinforced. At S rig I got for 645.52 mm square. At S prof I got for 1207 mm square. For the maximum moment at span 1 GL, for the K value I got for 1.0, which is more than K bar, 0.167. It is also doubly reinforced. At S I got for 533.96 mm square. At S prof I got for 1207 mm square.
For designing continuous beam, it concludes that the calculation to get the area reinforcement bar is at span 7 to 10 and at support of 10 because there is a maximum value of moment and shear. At the mid span, the beam is singly reinforced because the value of K is 0.007 less than K balance, which is 0.167. The area required for this design, I got 149 mm square, which between 83 mm square and 2880 mm square. Therefore, I provided the area of steel is 628 mm square, which is 2H20 to release tensile stresses, and 2 additional bar are provided in compression phase of the beam. The area provided is 402 mm square, which is 2H60. While at support, it is a singly reinforced because the value of K is 0.086 less than K balance value. The area required for this design, I got 320 mm square, which between 83 mm square and 2880 mm square. Therefore, I provided the area of steel is 628 mm square, which is 2/20 to release tensile stresses, and 2 additional bar are provided in compression phase of the beam. The area provided is 402 mm square, which is 2/60. After checking the deflection and cracking, I designed the spacing for the vertical sill link is has 6/125, while the minimum link near to the center of the beam is has 6/275.
So for the summary of this project, in conclusion, we have completed this project successfully, which is to study the design of the beam and slab that teach us on how to design a building in accordance with Euro code. Through calculations from this project, we are able to apply our engineering knowledge and improve our skills in civil engineering, such as when we need to use AutoCAD to create the beams detailing. We have already accomplished the project objective, which were to design a beam and use calculation to determine the condition of the construction.